Welcome to today's deep dive. We are just so thrilled to have you with us today because, well, we have a massive mission. We are unpacking a huge, brand new announcement from late yesterday.
Yeah, March 21st, 2026, a date we might actually remember for a long time.
Exactly. We are talking about Elon Musk's $20 to $25 billion Terafab project down in Austin, Texas. And our goal today for you listening, it isn't just to regurgitate the morning news.
Right, because on the surface, it really just looks like a standard, business supply chain story.
Oh, totally. But we want to connect the dots between this Texas chip factory, the actual physical limits of Earth's energy grid, digital immortality, and the cosmic evolution of human civilization.
Which sounds like sci-fi, but I promise you, the roadmap is hiding right out in the open.
It really is. And to do this, we've pulled together a wild stack of sources. We've got the breaking news articles on the Terafab joint venture, obviously. But we also have this highly, highly skeptical Reddit thread from hardware engineers.
That thread is absolutely brutal, by the way.
Oh, they do not hold back. We're also pulling from a futurist newsletter about AI energy consumption, a deep philosophical piece on consciousness uploading, Wikipedia's breakdown of the Kardashev scale, and surprisingly enough, a YouTube tutorial on how to write viral story scripts.
Which actually ties it all together beautifully.
It really does. So the hook here for you listening is this. While this looks like a business headline about silicon, it is actually a real-time attempt to rewrite the biological and energetic limits of humanity.
Yeah. To understand what's actually being built, you really have to look past the PR and, well, look up at the sky.
Okay, so let's start with the surface story, the raw facts from the announcement.
Right. So Tesla, SpaceX, and xAI are forming a joint venture. They're building a massive semiconductor fabrication plant, a fab, in eastern Travis County, Austin. They're calling it Terafab.
Terafab. Got it.
And the stated goal is to produce 1 terawatt of artificial intelligence computing power annually by 2027.
Wait, 2027, that is like tomorrow in infrastructure years.
It's incredibly fast, and we really have to pause on that 1 terawatt number. The ambition is to eventually scale this single facility to rival about 70% of TSMC's total global output.
Wow. And for context, TSMC, the Taiwan Semiconductor Manufacturing Company, they are the undisputed heavyweight champions of the world.
Oh, absolutely.
They essentially print the brainpower of the modern world. So aiming for 70% of their output with a brand new vertically integrated facility is just a staggering target.
And when they say vertically integrated, they mean everything is in-house. They aren't just taking an NVIDIA design and printing it. They are designing their own custom chips. They call them D3 chips.
Right, and here's the detail that immediately caught my eye in the specs. These D3 chips, they are specifically engineered to be incredibly radiation resistant.
Yes.
And capable of withstanding these extreme violent temperature fluctuations, which is a huge tell.
It's the immediate tell. I mean, your laptop or even the computer driving a Tesla down the highway, it doesn't need to be hardened against intense cosmic radiation.
No, definitely not.
The ultimate destination for these D3 chips isn't cars, it's space.
Exactly. Because outside the protective bubble of Earth's magnetic field, space is a highly radioactive environment.
Yeah, it's hostile.
If a random cosmic ray or a solar flare hits a standard computer chip, it can physically flip a 1 to a 0 in the memory.
Right, a single event upset.
Exactly, and that will instantly crash a system, so you need specialized silicon. Yeah. But the question is, why are they sending all this AI compute into orbit?
Well, the Terafab output is deeply tied to a new SpaceX initiative. They plan to launch a constellation of up to 1 million of these AI-sat mini satellites.
For a million.
A million. And each satellite will be powered by 100 kilowatts of solar energy. So when you network them all together, they're effectively creating this unprecedented orbital data center.
Okay, I want to give an analogy to make this scale relatable for everyone listening. It's like trying to build the entire global internet, the national power grid, and millions of supercomputers all at exactly the same time. And then, once you've done that, deciding to pack the whole thing onto rockets and shoot it into the thermosphere.
It's wild when you say it out loud.
It's an infrastructural project on a scale that is genuinely hard to wrap your head around. But, as with all things of this magnitude, the pushback has been intense.
That is putting it mildly.
Let's bring in that Reddit thread.
Yeah, so if you look at the discussions happening right now among hardware engineers, the disbelief is like a physical wall. The core criticism they have is that Musk has zero experience building a chip fab.
Which is fair.
Building one from scratch requires decades of highly guarded institutional knowledge. You don't just pour concrete and start printing 1 nanometer chips.
Right. I was reading through these engineering forums, and one of the biggest bottlenecks they point out is extreme ultraviolet lithography, or EUV.
Oh, yeah. The ASML machines.
Exactly. And for anyone not deep in semiconductor manufacturing, EUV isn't just a fancy laser. You have to fire a high-power laser at microscopic droplets of molten tin.
At like 50,000 times a second.
Right. Vaporizing them to create light with a wavelength so short it's invisible to the human eye. And then you bounce that light off flawless mirrors to print a circuit that is literally a few atoms wide.
It's basically black magic.
It really is. And only one company in the world, ASML, in the Netherlands, makes the machines that can do this.
Precisely. And the critics are pointing out that Terafab is going to have this massive, inevitable reliance on ASML and other tech giants.
You can't just vertically integrate your way out of needing those machines.
No, and there's a years-long wait list just to buy one. One hardware engineer on Reddit bluntly stated, without them, the fab will just grind to a halt.
And the timelines are taking a beating too. As we said, the official target is 2027. But one commenter joked, plan 2029, actual 2049.
Yeah, because traditional fabs take 4 to 5 years to build under absolutely ideal conditions by companies who already know exactly what they're doing.
So hitting 2027 defies all historical precedent, which actually brings up a really fascinating way to look at this whole narrative.
The YouTube scriptwriting source.
Yes. So according to these viral scriptwriters, every good story has a surface problem and a deeper problem. It's the classic hero's journey. You have the status quo, the call to adventure, and the crisis.
Right. So right now, the surface problem is this looming global chip shortage and our heavy reliance on foreign foundries like TSMC.
Exactly. Musk is pitching himself as the hero answering that call to adventure. The PR narrative is brilliant because it aligns with governments wanting semiconductor sovereignty.
It solves the surface problem perfectly.
But I have to push back here on behalf of the critics. Is this a genuine hero's journey? Or, as some of those Reddit critics argue, is it just a scam to siphon government funding?
Or a distraction from other delayed projects.
Like the Dojo supercomputer. So I have to ask you, if making chips is just the surface problem, what is the actual deeper problem here?
Okay, so if we pull from the futurist newsletter we read, Synthetic Minds, the deeper problem becomes really obvious. Terafab is not actually a semiconductor strategy.
It's not.
No, it's an energy bet.
An energy bet. Okay, walk us through that.
It basically comes down to the physical limits of our planet. Earth is a closed system. It's a terrarium. We only have so much physical space. We only have so much electricity we can generate. And crucially, we only have so much heat we can safely vent into the atmosphere. And right now, humanity's push for advanced AI is slamming into the glass ceiling of that terrarium.
It's the heat problem. Because if you walk into a major data center today, the noise is deafening. It's just thousands of industrial fans blowing cold air over melting servers.
Alongside millions of gallons of water for liquid cooling.
Exactly. You physically cannot scale that infinitely on Earth without boiling rivers and collapsing the power grid.
Right. Even with infinite chips, we don't have the power to turn them on or the cooling to keep them from melting. Earth's limits are the bottleneck. But space solves this.
Okay, wait, I need to stop you there. Space is a vacuum. You can't use fans in orbit because there's no air to carry the heat away. How does space solve the cooling problem?
It's a great point, and it's a massive engineering hurdle. Conduction and convection don't work in a vacuum, so you have to rely entirely on thermal radiation.
So radiating the heat away.
Exactly. You design massive radiator panels to bleed that server heat directly into the dark void of space as infrared radiation.
Oh, wow.
It requires completely rethinking how a computer physically operates, which is exactly why Terafab is designing custom D3 chips from scratch.
Ah. So you design a chip that runs hotter, is radiation-hardened, and you pair it with thermal radiators pointing into deep space.
Yes. And on the flip side, space gives you essentially infinite power.
Because of the sun.
Right. In orbit, solar irradiance is roughly 5 times greater than on the surface of the Earth. There's no atmosphere filtering it, no weather, no day-night cycle.
Continuous unfiltered power.
Exactly. The thesis of Terafab is that terrestrial computing has a hard physical ceiling. For AI to truly scale, it has to move to orbit.
Which raises a terrifying structural risk that was mentioned in the sources.
Yeah.
The governance question.
Yeah, this is huge.
Think about this for a second, for everyone listening. If one single individual controls the launch vehicles via SpaceX, the space internet via Starlink, the chips via Terafab, the AI software via XAI, and the physical robots via Tesla, who governs that?
It's a concentration of infrastructure with zero precedent.
Right. We have laws for Earth, but what happens when the cloud is literally in the stars? How does a government subpoena a decentralized network of 1 million satellites in a vacuum?
They probably can't.
Okay, so let's follow this to the end game. We have 1 million satellites in orbit, soaking up solar radiation, bleeding waste heat into the void, processing insane amounts of data. What is all this compute actually going to be used for?
Well, according to the piece from Punch newspapers we reviewed, the ultimate application for this bandwidth is the uploading of human consciousness.
Digital immortality.
Exactly. The concept uses advanced brain-computer interfaces, specifically Neuralink, to map the human brain's 86 billion neurons.
All right.
The idea is to capture your memories, thoughts, and personality as incredibly complex data packets.
It's so fascinating because Musk has often called spoken language lossy compression. The idea that our brains have these rich, multidimensional feelings, but we have to squeeze them through our vocal cords into clumsy words.
And nuance gets lost.
So much nuance. So the goal here is to take the entire human experience, compress a lifetime into a zip file, and email it to an Optimus robot.
Or an orbital server.
Basically, yeah, direct mind-to-machine communication processed by vast AI arrays in orbit to survive potential Earth extinction.
It makes you wonder, does the soul survive the file transfer? Which brings up some immense ethical and religious dilemmas. We really need to talk about the philosophy here.
Yeah, Derek Parfit's teleporter paradox.
Yes. For anyone unfamiliar, philosopher Derek Parfit proposed a thought experiment. Imagine a teleporter that scans your body to the subatomic level, destroys the original you, and beams the data to Mars to print an exact replica.
And the replica has all your memories. It thinks it's you.
Right. But did you travel to Mars, or did you just die in a scanner while a clone woke up on another planet? It's the ultimate identity crisis. If Terafab backs up your mind to an orbital server, the file of there thinks it's you. But the biological you on Earth is still sitting in a chair, aging, and eventually dying.
Are you you or just a copy? And when you bring world religions into this, the friction is just immense.
Oh, absolutely. The theological treatises we read were fascinating on this. In Christianity, for example, resurrection is strictly God's domain.
Right. Seeking digital immortality would be seen as a modern Tower of Babel, a massive overstepping.
Exactly. And Islam places heavy emphasis on the soul's journey post-death, the barzakh, that intermediate state. Theologians would debate if a digitized mind even has a soul, or if it's just a soulless echo.
And what about Eastern philosophies? Hinduism, Buddhism?
They focus on the natural cycles of karma and reincarnation. Intervening with technology to artificially freeze an ego disrupts the cosmic order. The goal of Buddhism is liberation from attachment, not uploading your ego to a satellite to live forever.
And even stripping religion away, the secular ethics are wild. We're talking about a digital elite where only billionaires can afford server space to back up their minds.
In the cybersecurity aspect,
The idea of a hacked mind is chilling. Your consciousness hosted on a server could be rewritten or paused or subjected to endless manipulation.
you'd be moving from biological organisms shaped by evolution to digital entities shaped by server capacity.
Okay, my mind is completely spinning. But we actually need to zoom out even further because the Wikipedia source we pulled,
Yeah.
it connects all this energy consumption and space expansion to a 60-year-old astrophysics theory.
The Kardashev scale.
Yes.
If you want to grasp the cosmic context of Terafab, this is the framework. It was proposed in 1964 by Soviet astronomer Nikolai Kardashev. It measures a civilization's technological advancement based entirely on its energy use.
Break down the scale for us.
Sure. Type 1 is a planetary civilization. They can harness all the energy available on their home planet. Type 2 has outgrown its planet and can consume the entire energy output of its home star. This is usually done through a megastructure called a Dyson sphere or a Dyson Swarm.
A swarm of satellites around the sun.
Exactly. And Type 3 spans its entire galaxy.
So mathematically, where does humanity sit right now? We aren't type 1 yet, right?
No, far from it. Carl Sagan actually calculated that we are currently at a Type 0.73 civilization.
Type of 0.73. So we're basically still just digging up dead dinosaurs and ancient ferns and setting them on fire.
Pretty much. But reaching Type 1 is the dangerous part. Futurists call it technological adolescence. A civilization discovers how to destroy itself with nukes or AI before it learns to harness its planetary energy.
And this connects perfectly back to Terafab. The energy limits on Earth align exactly with Kardashev's theory.
Yes. A civilization maxes out its planetary energy budget, risks overheating its terrarium, and must expand into space to harvest stellar energy if it wants to keep growing its compute power.
Wait, so Musk's 1 terawatt factory feeding 1 million solar-powered satellites. That's essentially the early stages of a Dyson Swarm.
It is the textbook definition of the beginning of a Type 2 megastructure.
That is insane. And earlier you mentioned thermal radiation bleeding waste heat into the vacuum of space.
Yes, as infrared radiation. And here is the kicker. Scientists actually use that exact thermal signature to hunt for alien supercivilizations.
Are you serious?
Yes, the SETI program looks for mid-infrared radiation anomalies. They are literally looking for the waste heat of alien computer servers running in space.
Wait. So we've spent decades pointing telescopes at the sky looking for alien megastructures or Dyson spheres, but we might literally be drawing up the blueprints for one right now in Austin, Texas.
We are. Terafab is a primitive, highly localized step towards stellar engineering.
Okay, let's just briefly recap the incredible narrative arc we just traveled here. We started with a business announcement about a chip factory in Texas.
Right.
Then we uncover the hidden energy crisis driving that factory into space,
Which revealed the philosophical quest to upload the human mind.
and how all of it maps perfectly onto humanity's evolution toward a Type 1 civilization on the Kardashev scale.
And for everyone listening, this is why it matters today. Even if the Reddit critics are right and that 2027 timeline slips to 2049.
Which probably will.
Yeah, probably. But the groundwork for a digitized, spacefaring, vertically integrated human future is physically being laid right now. It completely challenges our definitions of governance, life, and mortality.
It really does. It makes you look at the night sky completely differently. But I want to leave you, the listener, with one brand new lingering question to ponder long after this audio stops.
What's that?
If we successfully upload a human consciousness into a space-based Terafab server, and we eventually beam that digitized mind across the galaxy using lasers,
Yeah.
does human consciousness eventually become the exact extraterrestrial intelligence that the Kardashev scale was originally designed to search for?
Wow. We expand into the cosmos, only to become the very aliens we've spent a century trying to find.
Something to think about the next time you look at the stars. Thanks for joining us on this deep dive.